Hello students, welcome to day one of our Android development course. My name is Joy, and today we are starting our journey to learn how Android applications work from the inside and how we can build professional apps step by step. Today we will cover what Android really is, how Android works internally, Android components, application structure, architecture layers, tools required. Let's begin. What is Android? Android is a mobile operating system developed by Google. It is open source, highly customizable, and runs on millions of devices like smartphones, tablets, TVs, smartwatches, car systems, and much more. It is built on top of the Linux kernel, which gives stability, performance, and security. Every Android app runs in its own isolated space, which keeps apps safe and prevents unauthorized access. Why Android? Android is the most widely used mobile OS in the world. This gives developers huge opportunities to create apps for businesses, startups, and real-world users. Android allows us to build apps for almost every industry: education, banking, health, retail, entertainment, travel, and more. Application components. In Android, an application is built using 4 core components. Every app in the world uses these components in different ways. 1. Activity. It represents a single screen with a user interface. 2. Service. It performs operations in the background without a UI. 3. Broadcast receiver. It listens to system-wide events such as battery change, network change, power on/off. 4. Content provider. It manages structured data, such as contacts, media, or your app database. Android activity. An Android activity represents a single screen in an application. Whenever you open an app and see a user interface, such as a login form, a home page, or a settings page, each of those screens is an activity. The activity is responsible for handling all user interactions on that screen. This includes handling button clicks, reading text inputs, displaying lists, and managing UI components. Every activity goes through different states in its life cycle, such as starting, running, paused, stopped, restarting, and destroyed. These states are managed by Android automatically, based on how the user interacts with the app. For example, when you open the app, the activity enters the created and started states. When another screen appears on top, the activity goes into the paused or stopped state. And if the user leaves the app completely, the activity might be destroyed. Understanding the activity lifecycle is extremely important for building stable Android apps, because it helps us manage data, stop unwanted tasks, and restart the screen properly when needed. In simple words, the activity is the heart of your app's user experience. It controls everything the user sees and interacts. Android service. A service is a component that performs tasks in the background without showing any user interface. It is designed for operations that need to continue even when the user is not actively interacting with the app. For example, imagine a music player app. Even if the user opens another app, the music continues to play. This is possible because of a background service. Similarly, when your phone fetches new emails or updates your location quietly in the background, services are working behind the scenes. A service is ideal for tasks like network requests, downloading or uploading files, tracking the user's location, or synchronizing data with the server. Services can run in different modes. A foreground service continues running with a notification, making sure the user knows it's active. A background service runs silently, but newer Android versions place strict limits on these. Bound services allow an activity to directly connect and communicate with a service. Overall, a service is used when you want your app to perform long-running or continuous operations without blocking the user interface. Broadcast receiver. A broadcast receiver is a component that listens for system-wide or app-wide broadcast messages. It responds whenever a specific event occurs, even if the app is not running. Android sends many broadcasts automatically. For example, when the battery level is low, when the device connects to or disconnects from the network, when the date or time changes, or when the phone has just completed booting. Your app can also send and receive custom broadcasts for internal communication. When a broadcast receiver detects an event, it can start an activity, trigger a service, show a notification, or update some part of the app. A simple example is receiving an incoming SMS. The broadcast receiver gets notified, and then your app can read the message or show a notification. Another example is detecting network connectivity changes, which helps apps adjust their online features. Broadcast receivers can be registered in two ways, statically in the Android manifest, or dynamically through code while the app is running. In short, a broadcast receiver reacts to system events and allows your app to stay aware of important changes happening on the device. Content provider. A content provider is responsible for managing and sharing application data. Its job is to provide a standardized way for apps to access structured data, whether that data is stored in a database, a file, or even on the device storage. Each content provider exposes a URI, a Uniform Resource Identifier, which acts like an address for the data. Using this URI, other apps can request permission to read or write data. A very common example is the Contacts app. Your phone stores all your contact information using a content provider. When WhatsApp or any other app wants to read your contacts, it does so through this provider. This ensures security because the provider checks permissions before sharing any data. Content providers are also used for photos, videos, audio files, app settings, and many system-managed collections like MediaStore. If your app handles or stores important data and needs to share it with other apps, content providers are the recommended and secure way to do it. In short, a content provider ensures safe, structured, and permission-based access to data. Android architecture. Android is designed in multiple layers. Each layer has a very specific responsibility. 1. Linux kernel. This is the foundation. It interacts with hardware like display, camera, Bluetooth, storage, etc. 2. Runtime and core libraries. This includes the Android runtime, which executes app code. This also handles memory management, performance, and compilation. 3. Application framework. This layer contains managers like Activity Manager, Window Manager, Location Manager, a Notification Manager, Resource Manager. These managers provide common functions used by all apps. 4. Applications layer. All apps like phone, messages, WhatsApp, Instagram, all run on this top layer. How an Android app runs. When you tap an app icon, the system performs several steps, creates a process for the app, loads the required classes, launches the main activity, draws the UI on the screen, interacts with system services, responds to user actions. This entire flow is managed by Android's framework. Android application structure. When we create a new project in Android Studio, we get many folders, a manifest app configuration, a Java/Kotlin app logic, a res layouts, images, icons, strings, a Gradle build system. Each family of files has its own purpose. Tools required for development. To build Android apps, we need Android Studio, JDK, Java Development Kit, Android SDK, emulator/virtual device, the real Android device for testing, optional. Android ecosystem. Android supports multiple platforms like phones, tablets, wearables, TV, and automotive systems. There are millions of apps on the Play Store, and developers can publish their apps to reach global users. What you will learn in this course. In this course, we will learn every concept required to build professional apps, UI design, layouts and components, user interaction, storage, shared preferences, internal, external, SQLite,
media, camera, audio, video,
app lifecycle, app publishing, final project development, Day 1 summary and homework. Today we understood what Android is, how it works, and its structure. Your homework for today is list the latest Android versions. Write the name of 4 application components. Search what an Android manifest file does. Thank you, students. In the next video, we will install Android Studio and understand the complete project structure.